Okay, lesson 4.5, we're going to continue with our proving triangles congruent. This time we're going to use side angle side, or SAS, and we're specifically with right triangles, HL. So the first thing we need to do is that the angle between two sides of a triangle is called the included angle. So we're going to name some included angles, naming the angle, and I'm going to suggest that you use 3 letters even for the easy ones of H and J, just to be a little easier. So looking at, I'll highlight the first ones here, and you'll see how easy. So here's side GH, and here's side HI. And what's the angle that's formed by those two sides? Specifically, it's angle GHI. Looking at HI and IG, what would be the angle between them? HIG. Right there. We have IG and HG. So what's the angle that would be between them? HGI. Hopefully you see the trend here, that the common one is the vertex. The common point is the vertex. So JG and IG would be JGI. And the last one, IJ and GJ, would be IJG. And the reason that we need to know what an included angle is because side angle side is if two sides and the included angle, the angle in between the two sides, one triangle congruent to two sides, the included of the second triangle, then the two triangles are congruent. So if side RS is congruent to UV, angle R congruent to angle U, and side RT congruent to UW, then triangle RST is congruent to triangle UVW. So let's decide whether or not we have enough information. So we're going to look at our two triangles, and again we're looking for side angle side. So I have LMN and NOP. So I'm going to look, and I have, I do have N with O, MN with OP, sorry, LN with NP, and I do have the in-between angle. So yes, yes, you have enough info. And you can always write them down if you want. Oops, they're not angles. How about sides? Oh, it won't let me. All right, so let's do... Okay, next one. I do have AD and CB, but the angle I have is actually the two right angles. Am I going to be able to go, and we can mark this, can I go side, angle, side? No. So there's not enough info. That's not the angle, or that's... Okay, turning the page. I'm looking at these. Mark our congruent, e.g. congruent to itself. And then we have angle GED congruent to angle EGF. And we have side ED congruent to FG. So do they go in the proper order? Your side, angle, side. So yes. And then number 10, let's look what we have here. We have side. Oops. We have angle, but is it the included angle? No. All right, then we go to specifically right triangles. Remember the right triangles, the two sides are called legs, with the long side across from the 90-degree angle called the hypotenuse. That is where HL comes from. Okay? So if the hypotenuse and leg of a right triangle are congruent to the hypotenuse and leg of a second triangle, then the two triangles are congruent. So we're looking at hypotenuse BC congruent to the hypotenuse EF, and leg AB congruent to leg DE. Then triangle ABC would be congruent to DEF. Remember that the main thing you need is right triangles. Okay, so let's look at the next page. Decide whether or not we have enough info. So here we have H and H. We have BC congruent to BC, which is the L. So yes, we have HL. If BD is an angle bisector of ABC, then that means these two are congruent. And we have BD congruent to BD. If we can also write angle ABD congruent to CBD. Okay, and this is an angle bisector, and AD is congruent to DC, means that I also have a right angle here, and it will be on both sides. So while I have a lot of information going on here, what's most important is that I have side, angle, side. So yes, I have enough info. And the last thing we're going to do here is use diagrams. I put them on here so that you can label everything. So we're given that B and E are congruent. Angles B and E are congruent. BC is congruent to EF. It wants to use side, angle, side. What needs to be congruent? Well, the angle has to be between. So AB must be congruent to DE. Okay, looking at the next one. AB, DE, BC, EF, and it wants to use side, side, side. So what do I need to have? I need to have AC congruent to DF. And the last one I have right triangles. Okay, because angle A is a right angle and A and D are congruent. I have AC, DF, and these are L's, so I need the H, which would be BC congruent to EF. Finishing out the lesson, how can you use two sides and an angle to prove two triangles congruent? So if two sides and the included angle, I'm going to abbreviate here, INCL, angle congruent to two sides and the included angle. And then the other one is if you have a right triangle HO congruent to HO. I think that it just abbreviates it, you know, if it's of one triangle then to the another. And this ends the lesson.